Okay, one more video on proofs, adding in some more things that we already know. So remember, when you see pi over 2 minus x or theta, it doesn't matter, that's the same as 90 minus theta if you're used to thetas. And what does that mean? That means complementary cofunction. We did this in chapter 4a. Who's the complementary cofunction of tangent? Tangent does not have a co, so you throw a co in front of it and it's cotangent. So that's the same thing as saying cotangent x. So when I start my proof, I'll write the original one on top. Clearly the right-hand side is more simplified, so I'm going to mess with the left. First thing I'm going to do is replace this, and it's also on your cheat sheet, right? Your formulas page. That's the same as cotangent of x. I didn't change this, and that's what I'm going for. Now, I see lots of different trig functions written next to each other. Often when I see different trig functions, it's helpful to switch to sines and cosines. Cotangent is cosine over sine. Secant is 1 over cosine. When I have it like that and there's no addition happening in this problem, a cosine on top crosses out with a cosine on bottom. That leaves me 1 over sine x. And yes, I need to see every step. Reduce and show me what you get. Now we know 1 over sine x is cosecant x, I apologize. So using our complementary cofunctions in a proof. There's another one. Why don't you pause the video and see what you can do with this? So replace with your complementary cofunction. And if it's squared, that just means your cofunction is going to be squared. And then see if you can finish this one. Pause your video. So when you replace, you get tangent squared x plus 1 equals secant squared x. Do you recognize this as one of your identities? That is secant squared x. Done. However, if you forget that that's a complementary cofunction and you try to like distribute cotangent or something, which is not how math works, that's not how functions work, you will clearly get it wrong. Okay, even odd functions. Again, on your cheat sheet, and it is something we've discussed in previous videos or in class. There are two functions that eat the negative sign, is how I want to say it. Let me show you why over here really quickly. So all of our trig functions are on the unit circle, right? So you have your circle. Remember, the inside, the x is the same thing as theta. So if you go theta in that direction, and you just land on some point, right? Doesn't need to be anything special. That would give me cosine of theta. Well, if I go theta in this direction, that's negative theta, and I have some point, try to match it up because it's the same theta value, right? That'll give me cosine of negative theta. But cosine is the x value. Do those 2 points, assuming I drew it well, do they have different x values or the same x values? They have the same x value. Cosine of negative theta is going to equal the same thing as cosine theta, assuming I drew it right. And they line up, right? Because they're both on the right-hand side, which is positive. So cosine eats the negative. It just disappears. Reciprocal of cosine is secant. Secant eats the negative as well. It disappears. All the other trig functions, it gets pulled to the front. So cosecant, not one of the ones that eats it, so that gets pulled to the front. Secant is one of the ones that eats it, so that just becomes secant of positive x. We're shooting for negative cotangent x. Remember, sometimes I think to myself, negative cotangent, that's negative cosine over sine. So keep that in your mind. My side clearly has the wrong trig functions in it. When the wrong trig functions are there, I like to just go back to sine and cosine. Keep the negative in front, right? My negative is done. I have that, so just write that in the front. Cosecant is 1 over sine x over secant is 1 over cosine x. I'm still keeping it equal to the same thing. Well, there's a couple ways you can do this. You can try to do the fraction and fraction thing that I keep having you do, or you can flip and multiply, right? Keep the top, make it multiply, and flip the bottom. That's negative cosine over sine, which is negative cotangent x. So even odd functions in our proofs. See what you can do with this one. Deal with the even odds. Clearly we're keeping the right-hand side as it is. Deal with those negative thetas. We never leave a negative theta. It either disappears, if it's an even function, or it gets pulled to the front. Cosine is the one that eats it. That's just cosine theta. If it's not cosine or secant, then it gets pulled out front, leaving this side alone. Now what do you think we should do? So when we kind of want to separate these, right? Right now the left side is one fraction, but the right side, or one term, the right side is two terms. So in problems like this, you'll understand why when we get to the end, but let's multiply by the conjugate, 1 plus sine x. Top and bottom, 1 plus sine x. There's other ways to do this as well. So I'm going to distribute my cosine, right? Distribute into the parentheses. Cosine x plus cosine x sine x. On bottom, that's a difference of squares. You should be getting better at recognizing that and knowing what you would get if you multiply that out. 1 plus sine x times, I changed it to x's, I'm sorry. It should be thetas. I don't have time to go through and change all of those, but I'll change my last two, okay? Keep the same variable. It's going to look terrible. Let me just change the last part, but keep the same variable. Cosine theta plus cosine theta sine theta. And then when you multiply out the bottom, assuming the same variable was used, you should get 1 minus sine squared theta. Now, for the reason I chose to do that, I know you're going to get a 1 minus something squared theta on the bottom, and our Pythagorean identities are full of those, right? What is 1 minus sine squared in our cheat sheet? So I'm going to keep the top. So in our cheat sheet, that's cosine squared theta. Now that you have one denominator, right, there's no pluses or minuses there, you can separate that, right? You can do cosine over cosine squared. Remember, I say cosine, but I write the theta every time. And then you can do plus cosine theta sine theta over cosine squared. I'm basically just undoing the common denominator, right? I'm separating them back out into two equations. Now, cosine over cosine squared, one of those crosses out, and I'm left with 1 over cosine. Problem says plus. Cosine over cosine squared, one of those crosses out, and I'm left with sine over cosine. And what do you know? 1 over cosine is secant, and sine over cosine is tangent. So there's another example for you. That's it for today. We'll do more examples in class, and hopefully the more examples you see and the more examples you do on your own, right? These are 4 problems you could write down again and try them all by yourself again without looking at my work, the better you will get. Hope you guys are doing good.